In the last video, we learned what a statement is, and we said that the goal of this course is to explain what it is we're doing when we prove a statement, right? So when we know what a statement is, now we need to know what a proof is. So I can define a proof, and when you see this little equals def, that's going to mean definition. We can define what a mathematical proof is as just a proof of a statement, right? And the statement you're proving we'll call the conclusion, and anything that you use to get to that conclusion that is not proved, we'll call those assumptions, right? Things that you assume to be true, taken for granted in proving the conclusion. And there are a number of different kinds of assumptions. One, you can identify assumption by seeing the word let, right? Whenever you see a let, especially in mathematical proofs, you are witnessing the birth of an assumption, right? Somebody is saying, let's just pretend that this is what's happening, especially like when you're defining terms, these are used. So like if I could say, let, I don't know, let x equal 4, or something like that, right? I'm telling you, we're going to assume x equals 4, and I can prove to you something given that. Right? There's another type of assumptions that are identified as theorems. A lot of times in math textbooks or I guess in everyday math, you can have theorems that have been written down in some other place, and this is identifying it. The proof is identifying those theorems, but it's not actually proving those theorems, right? So we'll have to call those assumptions. And then finally, there are some assumptions that we have that were taken for granted between the reader and the writer, meaning like things that I don't have to prove to you, things that you already believe or things that we both agree on. I need to go from the things that we both agree on and prove from there. This is a big debate in philosophy too, by the way. Well, not a big debate, I should say, but I know a lot of people who study the dialogues of Plato get confused on how Socrates could feel like he's proving something, because in Plato's dialogues, Socrates is always talking to some guy and saying, hey, we both agree that, let's say, justice is, I don't know, taking care of the elderly, something like that, right? And given that we both agree on that, what can we prove? What is about justice? And people will say, well, that's not a real proof, because Socrates is just going off of what they agree on, but you can always question on what they agree on, right? He doesn't prove what they agree on. I won't really talk too much about it more than that, than identify that. Yeah, there you go. There's a little philosophy for you. Now, to use a proof P to show that a conclusion psi is true, you have to account for the assumptions. Right? In other words, you don't get to just assume a bunch of things and then get to a conclusion and say, aha, proved it, right? I mean, otherwise I really could just assume the conclusion, right? I could say, I want to prove to you that 2 plus 2 equals 4, right? All right, my assumption is that 2 plus 2 equals 4. My conclusion is, therefore 2 plus 2 must equal 4. Well, that clearly doesn't make any sense. You have to be able to account for the assumptions in some way, and there are a few ways to do that. Number one is just to do what we did with 3 here, right? The assumption 3 here. We just show that assumption is something that we both agree on, right? So I don't really actually need to prove it. We're going to both agree on it and go from there. Another way you can deal with these assumptions is to prove them, right? You could do the exact same thing you're doing for the conclusion you want to get to. Of course, this is not going the full length, getting the conclusion you want. This is just sort of like a step in the right direction, right? You're proving your assumption is what we'll call a lemma. A lemma is like that, a step in the right direction. It's a proof. It's not an assumption anymore because you've proved it. But at the same time, it's not your full conclusion. And finally, you can discharge an assumption, which I will show you what that is later. All right, so the book gives us this following example of a proof, and it says, let's identify what is the conclusion and what are the assumptions. Well, I see up here at the very top, it says proposition, right? And it gives you this proposition. Then it says proof. So down here, I'm assuming we're getting some assumptions. Up here, I'm assuming we're getting a conclusion. And the reason I'm doing that is because this proof is the work you do to get, when you say the word proof, you're talking about the work you're going to do to get to the conclusion, right? So I'm assuming that these are going to be all assumptions down here. Oh, I'm guessing that they're all going to be assumptions, and I'd be right. You see this then right here? That is my tip off. I'm seeing that in this proposition up here, this is what's being put forth, and I see, well, some stuff up here, and then I see, well, if you're given all that stuff, then you're going to get this stuff. That seems to be what we want to prove. So here is my proof right here, or here's my conclusion, excuse me, from the proof. Z to the n power equals r to the n power times cosine of n theta plus I sine n theta. And what are my assumptions? Well, I can see, even in the proposition here, I can see some assumptions. Remember, I'm going to use a different color, by the way. Let's use green. Remember, when you see let, that's a clue word. That's a clue word that you were going to see an assumption next. Let's say that z equals r times the cosine of theta plus I the sine of theta. That is an assumption right there. And there's another let. Let n be a positive integer. So n is a positive integer is another assumption. And then, of course, down here in the proof, you're going to have some more assumptions, and here's one of them. Theorem 6.1. Theorem 6.1, given this proof, I don't really know what Theorem 6.1 is, but I know that it is an assumption because they don't prove Theorem 6.1 anywhere. And then we have down here some extra stuff, right? I'll use prep to identify it. Given this stuff, right, given these green lines, I can see this guy right here, right? Given that I can conclude, it give you this conclusion, this guy right here, right? Well, this is a lemma, right? This is something that I'm proving on my way, on my way to my real conclusion, and then finally I get from my lemma to the conclusion that I want. Z to the n power equals r r times r. So that would be, r to the n power, and etc. So yeah, I've got everything that I want right here. I've used the assumptions to prove a lemma, and my lemma to prove the conclusion, which is the same thing. Let's see, let me get a different color. Get back to my red. This guy is the same thing as this. So yeah, there it is. That is a proof and a conclusion and assumptions.